Good afternoon, and I welcome you again to this deliberation on on geospatial modeling driven urban hazards and risk analysis, which commences from today and will be going up to 17th. So today we will talk about geospatial applications and hazard and risk analysis, especially for the urban region, and I will be basically covering an overview of the entire thing. So when we talk about natural disaster, it is basically the society which is as focus and all the components of the society, like for example the dwelling, the energy security, food security, water security, health security, the ecosystem services which we derive from the nature, the economy, the communication, the infrastructure, all the aspects of the community which are influenced by the event. So before we go further, let us just go for across the definitions of the different terminologies which we use when we talk about natural disaster and disaster risk management. So one of the most commonly used term is the hazard. So hazard is basically the disruption or loss due to the unexpected event which occurs. And this may be like cyclones, floods, earthquake, the series goes on. The next definition or next terminology is the exposure. Exposure is basically the component of the society which is affected, like the people, property, the various things on which the society depends on, like food security, water security, etc. And then comes the important term, that is a vulnerability. Vulnerability is basically the ability or inability of the society to resist the hazard. And this is dependent on various aspects like economy, environment, the adaptive capacity of the society, etc. And if we talk about the risk, it is basically the subset of all these three, that is hazard, exposure, and vulnerability. So risk is basically a function of hazard, exposure, and vulnerability of the society or the system. So with this background, let us talk about the disaster management risk and the framework behind it. So the formal disaster risk management framework was initiated in the Hugo framework of action in 2000, and this was basically identified for the next 10 years. That was from 2005 to 2015, which basically rested on three pillars. That is a risk identification, risk reduction, and risk transfer. When we talk about risk identification, it's basically the analysis and study of the historical hazard data, analyzing the data and assessing the changing hazard trends. It also involved the quantification and assessment of the exposed assets and the vulnerabilities and the risk quantification. When we talk about risk reduction, it is the preparedness which is the major part of it, and which involves early warning system, emergency planning, and the response capacities. Along with preparedness, another important aspect for risk reduction are mitigation and prevention. And it is for both long term as well as short term, or I would say medium term, at various sectoral level and sectorial level planning, like for example building a resilient infrastructure, having effective knowledge dissemination, etc. And finally we have the risk transfer, which involve various insurances, bonds, alternative risk transfer mechanisms, and other developing products. And this entire management framework was coordinated by the government and the various coordination institutions through information and knowledge sharing, and mostly education and training. So when this Hugo framework of action came to an end in 2015, there was a need to take this forward and evolve upon this. So in 2015, we had a Sendai framework. And this is very important because Sendai is the city which was affected by the 2013 tsunami. And it's basically to basically salute the resilience of the society of Sendai, as they could overcome the impacts of tsunami and get back in life within 1 year. The global community identified Sendai as the location for the next conference. And this meeting or the conference was aimed to achieve substantial reduction of disaster risk and losses in lives, livelihoods, and health, and also in economic, physical, social, cultural, and environmental assets of persons, businesses, communities, and countries over the next 15 years. And to achieve these outcomes, they identified 7 targets, which was to substantially reduce the mortality, the number of people affected, the economic loss, and impact to critical infrastructure and services because of natural disasters by 2030, and substantially improve the disaster risk reduction strategies, early warning and risk information system, and international cooperation to manage the disasters effectively by 2030. And to achieve these 7 targets, 4 priorities of action were identified, which involved understanding disaster risk, which as a technical person or a scientist, we translate into the physical basis of disaster or the science behind the disaster. And investing in disaster risk reduction for resilience, both developing the infrastructure and for space and ground. Third priority of action was strengthening disaster risk governance to manage disaster risk. So when we talk about governance, it's basically availability of correct information in least amount of time, so that the necessary necessary activities could be taken up, or necessary policy can be, or the necessary decision can be made. So in this, the most important aspect is the dissemination of information. And finally, enhancing disaster preparedness for effective response in recovery, rehabilitation, and reconstruction, which translates into effective early warning system and logistics. And during the same time period, we also had the Sustainable Development Goals of the United Nations, that is 17 Sustainable Development Goals, which are the goals for 2030, which involves the 17 goals of no poverty, zero hunger, good health and well-being, quality education, gender equality. The list goes on. And Sendai framework is actually inbuilt into all of these Sustainable Development Goals, as you see in this comparison. So if we see the different targets of Sendai framework and the different goals of sustainable development, we see a convergence of the ideas, like number of deaths, missing persons, and persons affected by disaster is to be reduced. Direct disaster economic loss in relation to global cost domestic products. Direct disaster economic loss in relation to GDP, including disaster damage to critical infrastructure and disruption of basic services. This is what we saw in the disaster we had a few days back in Turkey and Syria, number of countries with national and local disaster risk reduction strategies, and proportion of local governments that adopt and implement local disaster risk reduction strategies in line with Sendai framework for disaster risk reduction. So all of these aspects are in sync with the Sendai framework and sustainable development goals. So when we talk about space technology and the role it has in disaster risk management, ISRO has a robust disaster management support program, which is an institutional mechanism with a decision support center at National Remote Sensing Center. And this has been set up in association with the various nodal agencies like Ministry of Home Affairs, Prime Minister's Office, MOA, Cabinet Secretary, NDMA, NIDM, state agencies, NGOs, etc. And what this Decision Support Center does? It monitors the natural disasters, assesses the damage caused due to it. It maintains a national database, basically for emergency management. Then during disaster, it provides VSAT-based VPN for emergency communication. And it also plays an important role in strengthening the various early warning systems like the tsunami, floods, cyclones, cyclones, drought, landslides, etc. And some of the key developmental efforts which we see are various synthetic aperture radar, airborne as well as spaceborne, various communication system. It supports IoTs, and it's also providing the constellation of Earth observation satellites. And it has got key areas of research and developments like landslide and earthquake precursor studies, extreme weather events, forest fire risk management, etc. And we also provide our inputs for international commitments. Like ISRO is a part of International Charter on Space and Major Disaster, Sentinel, and UN Spider, where the space-based inputs are provided for the area where the disaster has occurred. So when we talk about space technology in disaster management, it covers the entire gamut, right from disaster event to relief, rehabilitation, reconstruction, mitigation, and preparedness. It provides information for decision through observation, temporal observation, which identifies the area affected and the extent of the area affected. And once we identify the area affected, it also helps us to provide the the location as well as the means to reach there through satellite-based location services. And during any disaster, the first thing to be affected are the terrestrial communication system. So satellite communication system plays a critical role in providing information from the ground zero to the people who are or the stakeholders for the extent of the disaster and the amount or type of relief required. So when we talk about the space-based observation, we have a suite of satellite sensors which provide different types of data, from high temporal resolution with large swath, which provide global level information, to medium temporal resolution with large swath, which provide a coarse level resolution regional level information, to medium spatial resolution for local level information, to a high spatial resolution for location specific information, which provides us information on the catchment characteristics, subcatchment characteristics, and the various infrastructures. So we can basically go from global to local based on our requirements. And most importantly is the ability of remote sensing to have a 3D imaging capability, which basically allows us to use the ability of satellite to capture imagery in two different angles and integrate them using a proper algorithm to provide a 3D virtual imagery of the Earth's surface. And this is very important because it helps us to identify or model the various flows, the direction of the flows, and the other important parameters which are important for saving lives. So when we talk about natural disasters in India, India is actually vulnerable to a wide range of natural hazards, particularly flooding, cyclone, drought, extreme heat waves, landslides, wildfire, earthquake. The list goes on. I think except for volcano, India has all the natural disasters which are available across the globe. Even in India also we have an active volcano, but since there is no habitation near it, so it is not considered a part of disasters. And studies show that because of climate change, the intensity, duration, and frequency of the various weather related shocks are likely to increase in future. So when we talk about geospatial technology for monitoring disaster, geospatial technology provides us temporal observations of the patterns and the locations of the information on the surface of the earth, which actually helps in developing the scientific understanding in form of various maps like hydrology maps, geomorphal maps, land use land cover maps, various structural maps. And once you have all this information overlaid on one another using GIS, we can understand the models and processes, which helps in forecasting the various events. And that forms the basis of the various early warning systems. So I'll just briefly go through the various disasters which we have. For example, when we talk about geological disasters, we have earthquakes, and there are many techniques which can help in observation and monitoring of the disasters, like INSAR for subsidence, mapping of various geomorphic elements like faults, folds, etc. Thermal anomaly, because due to earthquake, many of the times the various aquifers come in contact with the magma, which results in superheated steam escaping from the surface of the earth, which provides the thermal anomaly. But it's not just that. The network of continuously operating reference stations which we have across the world also provide information on the global plate motions, which are actually responsible for major earthquakes in the world. And this provides us a fairly good idea about the type of stresses which are being built. Apart from that, there are some experimental forewarning, like the TEC anomaly or total electron content in the ionosphere, which shows anomalous behavior before earthquake events, and things like that. Then we also have the geological disasters like landslides, which are very common in the mountainous regions and which are successfully identified, mapped, and also to some extent modeled using various geospatial techniques. I'll just briefly talk about the event which happened on 7th of February in 2021, which was basically a rockfall induced flash flood, which in Chamoli district of Uttarakhand. So on February 7th of 2021, there was a report at around 10 o'clock of flash flood or something like a dam burst in high reaches of Himalaya in the Chamoli district near Joshimath. So this was in the Rishiganga region. What actually happened was a huge chunk of rock, which you can see in the images on the left, actually broke off from a slope and fell around 2 kilometers below at the mouth of Rishiganga glacier. The impact was such that the energy released as a result of this impact melted all the permafrost which was there, and the entire slurry just rushed down the slope, something of around 30 to 45 degrees. And the slurry was, the impact was so huge that all the infrastructure and the habitation which were downstream up to Joshimath was impacted. And you can see the damage which was in Tapovan hydropower site, just around 30-35 kilometers downstream of that region. And the height of the slush was around 30 to 40 meters high, and this you can see in the image on the right lower corner, wherein you see the scar which was left by the wave which traveled down the hill. Apart from that, you also have the various hydrometeorological disasters. One of them is the flood. So Earth observation plays a very critical role in this particular aspect because it helps in identifying the inundated areas, especially using the radar data. But it is not just identification of the inundated area, which plays a very important role in rescue, relief, and the initial response. But geospatial technology can play a very important, or does play a very important role in early warning and risk analysis. For example, we have the real-time inputs of the projected rainfall as well as the inputs from the Doppler weather radar and the rain gauges, which provide us an idea about the hydrodynamic status or the flow or the discharge as a result of the rainfall. And once we have this information, we can have a simulation of a number of scenarios which can create a digital library of pre-computed flood maps. And moment there is input from the various ground-based and space-based sensors about the amount of rainfall, the most appropriate flood map can be retrieved from the library, and the inundations which are modeled, so those areas can be identified and people can be evacuated from that region. In fact, this particular system has been working in northeast in the Brahmaputra river basin. Then you also have the other hydrometeorological disasters like extreme weather events and flash flood. And one of the extreme weather event associated with flash flood was the Kedarnath disaster, which we had in 2013. So what happened was an extreme rainfall during 15th to 17th of June in 2013 triggered a number of landslides. But before that, what happened was that over Chorabari Glacier and Companion Glacier, this extreme rainfall event led to washing down of the various debris into the Chorabari Lake, which was a moraine dam lake, and this got breached. And since this Chorabari Lake was just above Kedarnath town, the entire water rushed into the town. And you can see in the video here, which was the first video flight after the weather cleared, so how the entire water rushed down from the Chorabari Lake on just over the Kedarnath and damaged the area. So Earth observation system can play a very important role in identifying the damages. But more than that, this entire video which you see could be captured only after the weather cleared. But before that, space technology actually helped in developing a digital fly-through of that area, which provided critical insights into the extent of damage and also the the inputs into how the rescue and relief could be carried out in this particular area. We also have a hydrometeorological disaster which is not that much spectacular, but has the capacity to damage the economy of a country. That is a drought. And here space-based inputs play a very important role in identifying the extent of the drought through various geospatial technique as well as space and ground-based sensors, but also provide a very robust early warning and risk analysis of drought early warning system, which can provide the area specific vulnerability and also decide the price trends of food and feed through various inputs like weather forecasting, as well as information on the moisture, soil resources, and the NDVI profile. And this basically provide us the time of occurrence, the spatial extent of the drought, and the duration and severity of the drought in this region. Then you have the tsunami, which is basically an underwater earthquake causing a ripple on the ocean surface, and as this wave goes towards the coast, it becomes huge and devastates the area or the townships which are there. But here also space plays a very important role by providing an early warning system, which basically constitutes a number of pressure sensors which are there at the bottom of the Bay of Bengal. And all these pressure sensors are linked to the GPS buoys. The moment there is an earthquake, the sensors sense the earthquake and provides the information to the GPS buoys, which are linked through communication satellite to the modeling and simulation center at Hyderabad. And this particular system basically has also already a pre-computed library of around more than 90,000 scenarios of various earthquakes, underwater earthquakes of various intensity. And based on that, they provide the early warning system to the population which are at the coast. And this is done through mobile, through radio, as well television, as well as through the loudspeakers along the coast. Then you have the other type of coastal disasters like sea level rise, storm surges, and incursion of salt water into the aquifers. Then you have the other coastal disasters like cyclones, which also influence a lot of coastal townships. In fact, the state of Odisha is one of the most affected states by cyclone in India. And space technology has played a tremendous role in basically the disaster risk reduction because of cyclones. Because space technology plays or is able to provide inputs for tracking the cyclones, which can identify the landfall and also the wind speed and associated rainfall along with it. In fact, if you all remember, in 1999, we had the Odisha super cyclone, wherein more than 10,000 people lost their lives. But in 2013, we had a cyclone which was even more in intensity than the Odisha super cyclone. But in this case, the number of people who lost their lives was in single digit. And it was because of the early warning system as well as the preparedness of the government to effective logistics that people could be evacuated to safer places, and the government was ready with the logistics to counter the damage because of cyclone. Then you also have GIS for disease, human health and disease surveillance. For example, the COVID status and the changes in the hotspot of COVID across India during the first and second phase of COVID, and of course the spatial modeling for heat waves. Because in the coming decades, this is one of the disaster which is going to affect the human, especially the urban life, the most. So the spatiotemporal variation in the heat wave hazard and how the land use and the land transformation plays a very important role for heat wave hazard has been studied, and geospatial technology, especially the thermal imaging, provides a very useful inputs, useful inputs for identification of the areas of heat wave risk and vulnerability. Then you also have the environmental pollution, especially those living in and around the national capital area of Delhi are well aware of the impacts of the atmospheric pollution during the months of October and November. So space technology can actually help in understanding the movement of the pollutants across the landscape. And here the atmospheric aerosol or the aerosol optical depth is retrieved through the MODIS data, from MODIS data, and it is basically observed that the origin of this atmospheric dust is actually across the border in the deserts of Pakistan-Afghanistan border. And from here the dust is carried over, and due to the Hindu Kush region, it moves right towards the Punjab plains and goes it. But here, because of the stubble burning, the pollution load is increased, and the more area around Delhi has a poor visibility and poor air quality. There are other hazards like industrial hazards, like oil spills, the identification of gas leaks or fire in the hazardous waste dumps. All of these can be identified using remote sensing sensors. And there are also other natural disasters due to the sea level rise. Inundation of the many of the areas or many of the cities which are a few meters above the sea level, especially for the island countries like Maldives. And in case there is increase in the sea level of around 2 to 4 meters, which has been projected by IPCC for the extreme scenario, many of these people will actually be displaced from the region. And in that case, this is going to cause a serious humanitarian crisis. Then you have the other disasters, specifically like the large-scale singular events, which are very difficult to visualize but has a greater impact. So I'll just elaborate one of them. So as we all understand that most of the climate is controlled by the ocean currents. There's a warm and the cold currents which we have. And these ocean currents are like the great conveyor belt, which basically goes from warm to cold and then again goes back. And this entire currents are going on through ages. So as a result of climate change, there has been indication that the polar sea ice, especially for the North Pole, is going to almost disappear by 2100. And if that is the case, this has a serious consequences. I'll just take an example of one of the ocean currents, which we all have heard about. That is the Gulf Stream. So the Gulf Stream is the warm current which originates from Gulf of Mexico, goes across Atlantic to the north of Europe, and there it meets the cold water from the polar seas. And due to the increase in the thermal haline conditions, this entire current, water mass cools down, becomes heavier and goes down. So the amount of water which goes down almost like a waterfall in this part of the world in 1 hour is more than all the terrestrial waters in all rivers, lakes, and other glaciers. So suppose because of the decreasing thermohaline condition of the Northern Ocean as a result of melting of the polar ice, the water doesn't become dense enough to go down, and this great ocean conveyor belt stopped. In fact, if that happens, half of Europe will be under ice. Because if you see the latitudinal extent of Europe and Greenland, it is almost the same. While Greenland is perpetually covered by ice, Europe is ice free relatively. So here, if this happens, there will be a serious crisis of the of food, because Europe is responsible for more than 20% of the wheat export across the world. Then you have the communication system, which is provided by the space-based communication network. So this is basically a virtual satellite-based virtual private communication network and is dedicated for disaster management support. So this consists of one hub station at Ministry of Home Affairs in New Delhi, and which is the primary node, and has user nodes spread across all the districts of the country. So this basically is capable of providing voice, data, and video traffic between any two nodes. And using this, in event of disaster, we can also use it for telemedicine. Another very recent aspect of use of geospatial technology is the crowdsourcing, which uses the social networking for prioritizing the relief and rescue. Like in Chennai flood, an app was developed which displayed an interactive map of city, and it allowed anyone to mark a street as flooded and also to identify the locations where priority evacuation was required. So this proved to be very, very useful for the rescue and relief, for identifying the location, for prioritizing the rescue, relief, and other aspects of disaster management. So when we talk about the GIS-based decision support tools, we need to identify what we need. So basically what we need is a seamless data from various sources with data processing algorithms, specific tools and models, computation infrastructure, and bring along the experts and decision maker in the process. So for this, we need integration of technologies, which include the remote sensing, GIS, GPS, web GIS, mobile apps, communication network, IT, and the database. And all of these, through various platforms and resources, especially IT resources, provide the various simulation models, forecasting service, incident reporting, relief management, decision support tools, and multi-scale geospatial services. So some of the possible data sources are space-based sensors, which provide observation, navigation, and communication, airborne sensors like UAV, the legacy data from data archives, ground sensor data using sensor network, and the crowd sensing data, which provide the inputs for the decision support system for disaster risk reduction, which helps in identifying where is what through mapping, and why and so what through modeling, which provide a suite of application for various disasters like food and water security, infrastructure and development planning, disaster management, environment and energy security, and the weather and climate. For this, as discussed earlier, NRSC is maintaining the National Database for Emergency Management, which is a beautiful system providing a disaster dashboard, incident reporting, data visualization, decision support tools, interaction portals, resource management, mobile apps, data inventory through a geospatial portal or geoportal. And this is equipped with comprehensive geospatial database for visualization, analysis, and decision making. Some of the examples are like proximity tools, network analysis tools, user-specific data tools, multi-layer analysis tools, which basically helps the user to analyze and assess in real time the various inputs required for decision making. So as part of our international commitment to major disasters, we are a part of Sentinel Asia, which provides information through space-based observation and WebGIS technologies to support disaster in Asia Pacific region, and also through International Charter for Space and Major Disaster for providing space-based information for disaster response. Thank you very much.